community is everyone is able to publish their rules, to push their rules to the community. So I would say there might be a lot of garbage rules. So we need effort to know which rules are meaningful. Second thing is that because it requires a large proportion of human work, so it could cost a lot. It needs a lot of specialists and professional knowledge. And the third one is even with specialists, sometimes humans can omit some really abstract and complicated features. Some features that cannot be explicitly displayed by humans. So what are some solutions for it? Well, recently deep learning is a trend that its main key features is that it can extract the features of the data set itself. So imagine if we have a tool that can automatically detect malware with the minimum requirement of specialists. So imagine the tool can understand some complicated features that even specialists cannot understand. So obviously, if we have that tool, it would be much more effective and more cost and time saving, right? Much more productive. So probably deep learning is the good way to go. But deep learning is not really new in this area. There are plenty of researchers who work on this, but they all have some pitfalls. For example, some work uses the RNN so that you can check the temporal features of the API that is called, but it will lack the interactions, the connections between the nodes between the API calls. So, or the second approach, which are recently, in recent years, pretty popular, is using graph, using neural network on graph. So with this technique, yes, it can take into account the interactions of different entities, but most of the existing works cannot interpret the more information of the API. For example, they can only express one entity as one node in the graph in name. You can express the node in name only, and it mostly ignore the arguments or the time of that API. And sometimes the arguments mean a lot, right? The same API, the different arguments like bypass or registry path, it can mean a totally different thing. So our method with SEF, we try to construct a graph that could represent all that kind of features. We want to represent the API name, API category, API argument, time, extract all the interaction between the process and the APIs it calls, and extract the importance of each node. I mean, the importance of each node here, I mean, when we have a process that calls multiple API. So if it comes to a malware, which calls are important? So the solution, this one, will try to extract the importance of each node. The final one will build this model, will try to extract the importance of each type of connection, because we build the graph that has multiple information. For example, some type of connection like process to network. I'll explain it later. Exactly how our solution works. First of all, we'll use cuckoo sandbox to collect behaviors of an executable. And the second phase, we're going to construct graphs. And how we're going to construct the graph? Well, first of all the nodes in our graph represented by the name of one of the interesting APIs. The interesting APIs here we get by analyzing some rules by specialists on the community, like that's submitted on Yara community. And Okay, those interesting APIs are those APIs that a malware usually calls, and all the nodes that we construct, we extract it to only 4 types of categories: registry, file, network, and process. Well, after analyzing the data, we come to this conclusion based a lot on previous researches and professional knowledge. Second thing is the edge of the graph. The edge of the graph here, well, each edge toward each node is the call to the corresponding API. For example, this one is the create key API. Then this edge will be its arguments or time or, well, anything you want, but we use argument and time. And there are 4 types of edges, and we call this metapaths. We have 4 metapaths. We have 4 types of edges, like the process connect to registry or reverse direction, process connect to file, call to file or reverse direction, process connect to network or reverse direction, 4 types, 4 metapaths. So we can see here, the graph we build is encouraging here directional graph, which means the graph itself already contains a lot of information. And the third phase here we do is to embed the graph. To come to the final equation, to come to the final vector of the graph, we use several layers, several networks. For example, here is the node level attention. Like I mentioned before, we're going to learn the importance of the neighbors nodes that connect to that node under a specific type of connection. For example, process connect to file. Then under that specific type of connection, how many nodes connect under that type, and the importance of each node, like that. After that, we're going to get the semantic specific features of each node, and then we're going to use the semantic level attention, another simple neural network, to learn the importance of each type of connection, each metapath. And finally, we're going to combine it, aggregate it with a weighted to get the final graph embedding. And this graph embedding, as you all know, this one is the visualization of our model. As you can see here, this is one type of connection. One type of connection, all kind of these neighbors that connect to this node under this type of connection are aggregated. So we can learn the attention weight of each kind of node like here. This aggregation here. All the semantic specific features aggregated into the final node embedding, and all these node embedding will be aggregated to get the graph embedding. And afterward, it will be fed into the final layer, to an expansion layer to predict. Our data set, I forgot to say, in the first phase, when we collect the data, we separate it into only 2 labels, malware or benign. And here are some of our results. We use a total 830,000 samples for training and testing in total. And we apply, I think it's quite impressive results. And the reason why I compare to these models is that, well, QDFG is, I think, the most popular model, most popular type of graph to represent a malware. There are pretty many research that based on it. And our team previously has worked on this model, GCN, and the author of this model is is here today too. He's our great teacher, and the result here in his paper, he's already compared to these methods. So, which is compared to our previous work, and he's sitting right over there. Okay, and so the features of our solution, I think, because we are a research group, so we aim for a solution that can be integrated easily into a system. And we know that professional knowledge in security is really, really important and cannot be replaced. So we know that it will be much more productive and efficient if we can combine the autonomous method with traditional method. And second, I think with deep learning, the more data we have, the better result we might acquire. Because with now, the feature space that we use for each node, the initial feature space we use for each node is pretty small because the data set is not really large. So if we have more data sets, we can work more on what kind of data, what kind of argument we should put into our initial features. And the third one is, well, we are a research group, so we would like to bring our solution to the research community. So we will open source our project, but of course, just to some extent, because we have a bigger ambition. Our future goal, of course, first of all, we'll collect more data and clean it and improve our model. We will work more on this model, but also experiment on some other techniques, other models. We have many people with creative ideas, and we already have some ideas in our minds. And the third one, is our bigger ambition. We want to develop an application that would, like I said before, combine the autonomous methods with traditional methods. Hope for a good result. This is just the first step of developing the app, because we're the research group, so we do not focus on the app too much. So we will focus on 3 types of scan photos, scan file, and auto scan. We're going to hook into the running process and scan that process. About the demo, because this system is pretty complicated and heavy, so our computer cannot run on it. So, but we're eager to invite you to our labs to review our work and many other deep learning solutions of us. And that is the end of our presentation. Thank you for listening.
Question from the judges?
Okay.
Actually, because we don't have a full staff here, so we have to very ask for a question. And my question is, why don't you publish the web interface so that for the community?
I know, we've already built the web interface, but the web is only local right now. Because, Lebanon Technical University is also military technical academy, so for some reasons we currently do not publish the request for anyone outside the school. But we're eager to invite you to our school.
Because one of the requirements for this application is we have to open source, right? Yes, we have an open source tool.
Open source the core, the architecture of the network, yes.
So I think that we should public that in some report like GitHub.
Oh yes, of course. I'm not really sure. I published it. Right now, I didn't push it to GitHub, but I have the code in my laptop. So if you want, I can open the code here. If you need. Yes, of course.
Can I just ask a question?
Okay.
The percentage you showed earlier about the positive percentage, so you have a 7% and the older model was like 9%. Was that running against the same set of testing data?
Yes.
So wouldn't that say that you're overfitting that particular set data? Because you should have run it against another different set of test data. Because now you're marking that is overfitting for that particular program. You know?
Probably okay. Just a little bit that I'll try because the data here is pretty hard to prepare, because the executable file is available a lot, but the thing here is our model, our architecture requires a lot. We construct the graph, and that is, you could say the pain in the ass. So of course we will spend more time in our future implementation, of course. Thank you for your feedback.
I have a question. So what is your kind of graph? Is it a 100 graph or 3 graph or everything with or not?
It is a directional graph, and like I said before, heterogeneous directional graph, whereas each contains multiple entities and multiple types of connections. There is a very interesting paper, research work on this type of graph, heterogeneous graph, that you might look on Google.
So what is each node stand for? I don't understand what each node stand for.
What does it stand for? Node?
Each node?
Each node. Oh, yeah, I'm sorry. Each node is each entity of the graph. The graph has multiple nodes.
Yes, I know that, but how about the relation?
How about
What's the relation between each?
the relation? Relation between the nodes. Yes, the node is 4 types of entity, like I said here. In here, 4 types of relations. All the API calls that belong to registry category, all the API calls belong to file registry, all API calls belong to this, and the process. If you use Cuckoo before, that you will know the format of the JSON, the JSON format of it, right?
Yes.
And you have the process that it has the calls that calls to multiple API functions, right?
Yes.
Yeah.
But I don't understand what is the real relation.
Like I said, one process that calls to multiple API. Then we have this process connects to calls to this API. This node is represented.
Each node has that feature, right?
Each node
that has the
yeah,
right feature.
has a feature.
So
And
as the node, where the relation is, as the node, not with the feature, as the node.
like I said, this node, this one is connected to this node, and because of it, the graph is directional, so there might be a direction from this one to this one, 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 right? So the interaction here is we're gonna extract the importance of each type of node, each node that connects to a specific node under a specific type of connection.
So how you present the node?
To present a node, here we use only the name of the API, and because we use only several interesting APIs, so we just one hot encoding it, and if it falls out of these APIs, we static others. And all important information here, like the arguments account, I put in the hash information, and we use an embedding layer here. At first, we try to represent all kind of API arguments and stuff like that in a node, but then it comes to a problem that one API with different arguments, it will contribute to different nodes, and like that, our graph will have so many nodes. And when it comes to like, I don't remember exactly how many, but I think about like 30 or 50,000, then our machine cannot handle it anymore. So we come to this.
How many features do you have?
How many features? You mean what kind of features?
Just how many total features do you have?
Actually, the edge information here, we use an embedding layer to extract the features. And the content that we put into this is the arguments of the API. Do I make myself clear?
Okay, can we leave the last question for the judges?
Okay.
Judges, do you have any questions?
Tôi hỏi một tiếng Việt. Có mấy câu hỏi này. Thứ nhất là dữ liệu khoảng 830.000 đúng không? Thì cái tính cân bằng dữ liệu hay là tính dữ liệu với bao nhiêu cái là có malware, bao nhiêu cái không có. Cái thứ nhất. Cái thứ hai là khi bạn khởi tạo, nếu bạn dùng cái phân tích thì những cái trọng số này, bạn dùng trên cái mô hình nào sẵn có hay là bạn tự training tự với vân vân. Cái thứ hai, thứ ba là nếu như mà sử dụng cái cuckoo phải gọi để có bắt các feature thì câu chuyện là thế data mới có bắt không hay là chỉ bắt trên cái đống dữ liệu ta có 30.000 cái sample nó sẵn hiểu gì?
Tức là có bắt có đi tích được nó là malware.
Đúng rồi.
Rồi, em sẽ trả lời lần lượt. Câu hỏi thứ nhất là về độ cân bằng của dữ liệu đúng không ạ? Dạ vâng, độ cân bằng của dữ liệu thì bọn em có thể đảm bảo là nó cân bằng trong khoảng là 50-50 balance.
Tức là bạn đã chọn cái balance rồi đúng không?
Dạ vâng, bọn em đã chọn được cái balance rồi. Vâng. Và bọn em cũng đã chọn cái độ đo để phù hợp với cái dataset này rồi. Cái thứ hai là về cái pre-train web đúng không ạ? Dạ không, bọn em không sử dụng pre-train web bởi vì cái phương pháp này của em là coi như là hoàn toàn mới, bởi vì cái cách biểu diễn với graph nó cũng mới và cái quy trình train, quy trình build các thứ là coi như nó hoàn toàn mới rồi đấy. Thì nhưng mà thời gian train thì nó không lâu đâu, bởi vì thẳng thắn mà nói thì cái mô hình của cái mạng này nó không phức tạp, mỗi cái attention network nó không phức tạp, nên thời gian train không lâu, mà thời gian train lâu, thời gian lâu chủ yếu là ở cái bước thu thập dữ liệu và clean data và xử lý dữ liệu. Câu hỏi thứ ba là về cái zero day malware đúng không ạ?
Yeah.
Thì zero day malware thì bọn em cũng chưa thử cái mô hình này, bọn em chưa thử cái mô hình này, nhưng mà cái mô hình mà mal GCN mà thầy em đã phát triển trước đấy thì là thầy đã thử trên những cái mẫu zero day và là nó đi tách được, bởi vì về mặt lý thuyết mà nói thì nó chỉ cần có một cái đặc trưng behavior như những cái con mà mình đã có trong train set thôi là nó có thể học được, chứ nó không cần phải có những cái signature explicit như kiểu khi mà mình apply một cái signature mà do con người định nghĩa ra. Thế nhưng mà trên cái bộ này em của nhóm bọn em phát triển thì bọn em chưa thử được cái đó.
Cái đấy khó để cũng là câu hỏi bạn vừa hỏi bao nhiêu feature của bạn nó hình thành dựa trên mỗi cái API có thể nó kết nối vào thì có thể tạo ra tập các cái đấy khác nhau. Cái đấy là cái mà nó không được định trước, giống như một cái zero day, một cái mới hoàn toàn thì chưa biết được cái behavior nó thế nào. Thì tôi nghĩ cái đấy là cái nghi ngờ nhất vấn đề chuyện là khi mà ứng dụng. Tất nhiên kết quả của bạn hôm nay của nhóm các bạn hiện nay mang tính là một cái research, viết bài báo sẽ là rất là tốt, nhưng mà đến sản phẩm thì đấy là câu chuyện tôi nghĩ là có những cái yếu tố.
Dạ vâng, để áp dụng vào thực tế thì bọn em cũng biết là bây giờ những cái phương pháp deep learning thì nó cũng chỉ mang tính là support thôi, hoàn toàn không thể thay thế được các phương pháp truyền thống. Thì vẫn cần rất là nhiều những cái hoạt động nghiên cứu thêm và tìm hiểu thêm và apply combination giữa các method với nhau. Nhưng mà cháu bọn em cũng khá là tin tưởng vào cái phương pháp này và cũng khá tin tưởng nó sẽ có khả năng detect được. Với cảm ơn.
Okay, thank you. Can we have three eyes of God on the stage, please?
Tụi này là chi biết nhau. Đẩy luôn. Nổi quá.
Như kiểu đang nói vậy.
Quá nhiều người là Node.js mà ok biết là mọi người chụp tất cả cái gì đấy, tất cả avatar của những người ở trên mạng nó trong cái Instagram nhưng mà đây cái slide và kể cả cái tiền nó bên nữa.
Mình cũng thấy các bạn là trình bày về AI và việc chừng mình là cái
Nhưng mà em bảo là support được Node.js, Python,
nó khác nhau được.